The first question we have is to give examples of fixtures that produce minor losses. So I have written down here some of those examples. You could have said contraction, confuser, entrance, an exit, discharge, expansion, bend, valve, an elbow, a Y, and anything like that is appropriate for that question. So this is question number 2, and I'm just going to solve one as an example. I might have to pause the video to blow my nose, but basically the best way to solve this is by drawing a sketch. You have a fire hydrant at the sidewalk and you need to put out a fire at the top of the building. We have the diameter of the pipe, the friction factor, the length of the pipe, the flow rate, how tall is the building, the fire hydrant pressure, the kinematic viscosity, and the specific weight. So there's 2 questions. What is the velocity in meters per second, and what is the pressure that can be maintained at the top of the building? So let me just draw a sketch here. You have a fire hydrant. It's not to scale, by the way. And you have a hose, and you have this multi-story building. I'm not very good. So what's important here is the head, which is 30 meters, and then the information that we have. You have the hose, and it doesn't matter in this case the length as much as the head, as I mentioned. Information about the hose: the diameter is 6 centimeters or 0.06 meters to keep everything in perspective. We have a friction factor of 0.02. The length is 100 meters. We'll see if we use this. We have a Q of 36 cubic meters per hour, and remember that base units would be in cubic meters per second, so that's 0.01 cubic meters per second, which is given. The viscosity is 8 times 10⁻⁷ meters squared per second, and then the specific weight 9,800 newtons per cubic meter. So this is going to be my point 1, and this is going to be my point 2. In everything, what's important is to always write the energy equation, and we're going to use it in meters as a head. So we have P1 over gamma plus B1 squared over 2G plus Z1 plus HP, and you always write everything, and then we'll start eliminating. Plus 2G plus C2 plus HT plus HL. So we always write it. Now, a couple of things we can eliminate here. This is point 1 and point 2. Since the diameter of the pipe does not change, the velocities will cancel. Oh, I forgot to put here the hydrant pressure. P1 is 1.6 megapascals, or 1.6 times to the 6 pascals. Okay, so the pressures are not the same. The elevation in Z1, this is my datum. So I established this as my datum, where Z equals 0, and then Z1 would be 0. There's no pumps, there's no turbines, okay, and there's losses due to friction. In this case, we did not include any minor losses. So now the expression would be, and again, this is V1 equals V2. I just want to make sure you have that note here. That's why we eliminated, not because there's 0, okay? So what I have is P1 over gamma equals P2 over gamma plus C2 plus the losses, okay? So P1 is given, so P1 is known. Of course, this is known. This is the question. This is known, and then of course we can calculate this. Can calculate. Okay, so now we have the information that we need. Okay, so let's start by substituting here to solve for P2. So P2 over gamma equals P1 over gamma minus C2 minus HL, or of course P2 equals P1 over gamma minus Z2 minus HL times gamma. So here is my expression. Okay. I guess I'll have to solve it here. So the first question was, let me add another slide. So the first question is what is the velocity? And the velocity, of course, is Q divided by A, and the Q is 0.01. We want to work with the basic units, so we don't have to worry about conversions. And then the area is based on the diameter, so it's pi. The diameter is 0.06 meters squared over 4. So here the velocity is 3.54 meters per second. So this would be the question number 1. The question number 2, of course, I started solving for that. So let's solve for P2. And you saw that it was pretty straightforward. P2 is going to be P1 over gamma minus C2 minus HL, and this, of course, times gamma. So here we have 9800 newtons per cubic meters. We'll put it like this. So P1 was 1.6 times 10 to the 6 pascals. And then again I have here 9800 Newton cubic meters minus 30 and minus HL. I still have not calculated. So let's go to HL. HL would be, remember the expression F, L over D, V squared over 2T. So this is where you use the length. Not for the energy calculation in the equation, but for the losses. If they had said that the losses were negligible, then you would not include that. But there's no way around ignoring them here. So this would be the losses 0.02, which is the friction factor. The length was 10 meters and the diameter 0.06 meters. the velocity was 3.54 meters per second squared, and then root 2 is 9.81. Okay, and this is going to be equal to 21.3 meters. So now I substitute that HL, and then P2 is going to be equal to 1097,260 pascals, or using usually we use, like in statics, 3 significant figures, so we say, okay, 1.09 times 10 to the 6 pascals, or 1.09 gigapascals. Okay, so this is P2, and we had, this is the second. So the beauty of having this, remember, you can pause it and go back if you don't understand something. Excuse me.